Okay, picking up where we left off with our example using the empirical rule for normally distributed data, which has this famous bell-shaped curve. So we're trying to find the area under the curve, and the empirical rule helps us with that, with the mu plus or minus how many, 1, 2, or 3 standard deviations. So we're looking at question 1. What proportion of assembly times are between 37 and 46 minutes? So we need to put that roughly on our plot here. So 46 would be 3 above the mean, which is 1 standard deviation, right? So we could go mu plus 3, or let's do it like this. So it's keeping it straight. Mu plus sigma equals 43 plus 3 gives us 46. That's the top number, and 37 would be probably about here, or maybe even less. So 37, remember, it's just a sketch. It does not have to be perfect. So we're trying to find the area under the curve between 37 and 46 minutes. So how far away, I guess it's below, so we want to subtract. How far away are we from 43 down to 37? If we go 2 standard deviations, that would be 43. If we only go 1 standard deviation, that would just bring us to 40, right? 40 would be here. That would be just 1 standard deviation. But if we're 2 standard deviations, that would be subtract 2 times 3. That would be subtract 6. That brings us to 37, which is our lower number that we want. So between the mean and 43, this is the 68 part of the rule. So 68, but not the full center 68, because we're only going above the mean. So 68 divided by 2 is 34%, right? Because we had 68%. And this is how far we are below the mean. So 43, we're 2 standard deviations below. So that's the 95% part of the rule. So divide that by 2, we get 47.5%. If we add those two areas up, we would then have 34% plus 47.5% gives us 81.5%. And that is our solution. What proportion of assembly times are between 37 and 46? Right? The solution is, the proportion is going to be 0.815 or 81.5%. Okay, so question 2, what proportion of assembly times are more than 49? So let me grab a different color here. 49 would be about here, right? 49. And more would be to the right of that value. So the area under the curve to the right of 49. Well, if we look, how far away from the mean is 49? The mean is mu plus, are we 2 standard deviations above? Well, 1 standard deviation above gave us 46. 2 standard deviations above will give us 49, right? Mu is 43. Plus 2 times 3 is 6, so 43 plus 6 gives us 49. This is the 95% of the rule, so that must be 2.5%, because 95% would be 5% left over, would make it 100. Divide that by 2, there would be 2.5% in each of the tails. So the solution for the second question is going to be 0.025 or 2.5%. Okay, so moving along to the z-scores. Now these are related to the normal distribution too. We are not going to use them in too much detail yet until we get to the normal distribution later on in the course. But for now, we will just know what is a z-score. This is when we can transform our data. So if we have a data value equal to x, and we subtract the mean of the normal distribution and divide by the standard deviation, we end up getting what is called the z-score. And you can do this to help you determine how much values in between two values or greater than, and we will look at more questions that use the z-scores later on in the course as well. Okay, so here is an example using a z-score. The time needed to assemble a particular piece of furniture with experience is normally distributed with a mean of 43 minutes, right? That's the same as what we had. Standard deviation, 3 minutes. What is the z-score for an assembly time of 49 minutes? So I will leave this with you. See if you can come up with the z-score, and we will pick up on the next video segment.